is a tool that enables you to test the effects of IAM access control policies before committing them into production, making it easier to verify and troubleshoot permissions. In this video, we'll demonstrate how to use the policy simulator for a typical use case, validating that a policy works as expected. To get the most out of this video, it helps to be familiar with basic IAM concepts such as IAM users, groups, and policies. First, go to this URL, policysim.aws.amazon.com. Remember the HTTPS. Now, authenticate as you normally would into Amazon Web Services with your username and password. Note that you can also use the policy simulator by using your IAM username and password. Now that we're in the tool, let's take a moment to look around. By default, you start off in Existing Policies mode. Existing Policies lets you explore your IAM users, as well as the groups they belong to, and the policies that are attached. This administrator policy, for example, allows access to all AWS actions and resources. You can also use New Policy mode, in which you can author a brand new policy from scratch and test it. In this video tutorial, though, we'll use some existing IAM resources. Let's take a moment to navigate back to our list of users. The user Alice has two policies that apply to her. The policy DynamoDB All is attached directly to her and allows access to DynamoDB actions and resources. She's also a member of the developer group. This policy denies access to Dynamo deletes, and remember that denies always trump allows. To simulate Alice's permissions, select the DynamoDB service, as well as from the list of actions. We'll just select all, and now hit Run Simulation. This will simulate Alice making each of the API calls, given that she is subject to both policies. Some are allowed, and some actions, like this one here, are denied. You can select Show Statement to see which policy element is actually denying access to the action. Now let's clear the results. What about another action type? If you select Redshift, for example, and select all actions, you can hit Run Simulation again. Here we see that all actions are implicitly denied. Remember that in policy evaluation, if an action type is not explicitly allowed, then it's denied by default. What if you want to change a policy and see its effects? Here, we'll go into the developer group policy and change it from a deny DynamoDB delete action type to allow all DynamoDB actions. Now, if you select DynamoDB service again, and then all actions, I'll remember to apply the policy. Now, if you hit Run Simulation, you can see that the actions are now allowed after the change that we made. Note now that there are two statements which are contributing to this allow. One, the DynamoDB All policy on the user, and the developer group policy on the group that Alice belongs to. Remember that the policy simulator is a sandbox environment, and changes don't take effect in production. To save policies, copy your changes from the policy simulator and attach them using the IAM console or command line interface. Now let's move on to a more advanced example. Let's go to user Frank and explore resource policies. Frank has a policy that allows access to S3, all S3 actions, but he also has a policy statement that denies access to a particular S3 bucket, in this case called My Custom Bucket. Let's test Frank's resource level policy by evaluating an action that affects a particular object in the prohibited bucket. Select S3 from the list of AWS services, and now let's try testing against S3 delete object, which you can choose from the list of S3 actions. If you run simulation, this action is allowed. That's because this is a generic action on S3. However, what if we were to get a little more specific? Here, we can specify the target resource for our request. We'll specify an Amazon S3 ARN. In this case, let's select an object in the My Custom bucket. The object can be called testObject.txt. If you simulate this action, note that the action is now denied because the target resource for the API call is in the prohibited bucket. If, however, we were to change the target resource to an object in a different bucket and rerun the simulation, this action is now allowed. And you can see that it's the S3 allow star policy that allows it. This concludes our walkthrough of the IAM policy simulator. To learn more about it,
Welcome. You'll now learn about AWS Systems Manager. AWS Systems Manager is a management service you can use to build an inventory of software used by your organization. You can also apply any necessary operating system patches, create system images, and configure Microsoft Windows and Linux operating systems. You can automate most of these tasks. For example, you can use the AWS Systems Manager run command to run scripts and programs on remote systems. You can also maintain an inventory of EC2 instance types and make sure that all your EC2 instances are installed with a consistent set of software on startup. You can also define a maintenance window to control when recurring administrative and maintenance tasks are performed on your instances, such as patching operating systems. Let's take a look at AWS Systems Manager in a little more detail. You can use the automation feature in AWS Systems Manager to define common IT tasks as a collection of steps in an AWS Systems Manager document. You can also author custom automations in JavaScript Object Notation or JSON. You can set up Amazon CloudWatch events to trigger AWS Systems Manager automations. Here's a general approach to developing and testing an AWS Systems Manager automation. First, create an automation document or use an existing automation template. This document or template includes sequential steps and parameters that AWS Systems Manager runs. Next, run the automation using AWS Systems Manager to do a few routine tasks, such as launching an instance, taking snapshots, or deleting old instances. Finally, monitor the automation workflow. After the automation finishes, confirm that the expected results were achieved. For example, you could launch a test instance from an Amazon Machine Image or AMI that was updated by an AWS Systems Manager automation to verify that it has the expected characteristics. You can use the AWS Systems Manager run command to run predefined commands against Amazon EC2 instances. A command that is run by run command reduces management overhead because a user can manage instances without setting up bastion hosts or managing keys and certificates from Secure Shell or SSH. Through integration with AWS Identity and Access Management, or IAM, you can apply granular permissions to control the actions that users can perform on instances. All actions taken with AWS Systems Manager can also be recorded by AWS CloudTrail so that you can audit changes throughout the environment. You can use the Session Manager feature in AWS Systems Manager to manage EC2 instances through an interactive browser-based shell that is accessible in the AWS Management Console. Session Manager provides secure and auditable instance management without the need to open inbound ports in the security groups, maintain bastion host instances in EC2 subnets, or manage SSH keys. Session Manager also makes it straightforward to comply with corporate policies that require controlled access to instances, strict security practices, and auditable logs that contain instance access details. There are several challenges associated with patching servers and instances, including the time that it takes to patch multiple EC2 instances or on-premises machines, the repetitive nature of the task itself, possibly introducing errors that can result in downtime, and potential compliance issues. You can overcome these issues by using the AWS System Manager Patch Manager to automate patching. You can accomplish this by first creating a patch baseline, which contains rules that automatically approve or reject patches. Next, you can define a maintenance window and group instances together for patching. You then apply patches in the maintenance window and reboot every instance in the patch group. Finally, you review the results and the details for patch compliance. You can use the AWS Systems Manager maintenance windows to schedule regular tasks like patching to run automatically. You can set limits for simultaneous activities and allowable error rates. To implement a maintenance window, you must first create a maintenance window. Next, assign targets that will use the maintenance window. Then, you assign tasks to be performed on those targets. Types of tasks that can run include commands run by AWS Systems Manager Run command, AWS Systems Manager Automation workflows, AWS Step Functions workflows, AWS Lambda functions. Finally, you review the status of the tasks once all commands are finished. AWS Systems Manager State Manager is a secure and scalable configuration management service that automates the process of keeping your EC2 and hybrid infrastructure in a state that you define. You can install software when you create EC2 instances, download and update agents, configure network settings, join a Windows domain, patch instances with software updates, and run scripts on Linux and Windows managed instances. Here's how AWS Systems Manager State Manager works. First, create the AWS Systems Manager, or SSM, document, or identify an existing one that defines the actions that AWS Systems Manager will perform on your managed instances. Documents are authored in JSON or YAML. They include the steps and parameters that you specify. Next, associate your managed instances with the SSM document. When you create the association, you define the schedule for how often to apply the configured state. Finally, when you create the association, you can choose to write the output of the commands to an S3 bucket where you can review the results at a later time. Instead of storing sensitive data in configuration files or hard-coding them into source code, you can use the AWS Systems Manager Parameter Store to store these parameters. You can then reference this information in applications or scripts. You can use AWS Systems Manager Parameter Store to store configuration information such as passwords, keys, license codes, or database strings. In the example here, a new parameter has been created to store a password. The parameter name is then referenced in the code shown on the right. AWS Systems Manager Parameter Store integrates with IAM to control parameter access, and then the stored information can be encrypted with AWS Key Management Service, or AWS KMS. At the time of this video, SSM documents do not support references to secure string parameters. This means that if you want to use secure string parameters with, for example, run command, you must retrieve the parameter value before it is passed to run command. You can use the AWS Systems Manager Inventory feature to collect inventory information about EC2 instances and the software installed on them. For example, you can collect application data, network configurations, server roles, files, updates, Windows services, and even system properties. The AWS Systems Manager Inventory feature can help provide a comprehensive understanding of system configurations and installed applications across multiple instances without the need to log into each instance individually. You can use the gathered data to support the management of application assets, license tracking, file integrity monitoring, the discovery of applications that weren't installed by a traditional installer, and more. You can view operational data using the AWS Systems Manager Built-in Insights feature. AWS Systems Manager Built-in Insights provides aggregated operational data for each resource group through a dashboard. This dashboard reduces the need to navigate across multiple AWS service consoles to view operational data. In this dashboard, you can view Application Programming Interface, or API calls from AWS CloudTrail, resource configuration changes from AWS Config, your software inventory, and also patch compliance status organized by resource group. Hello, you'll now learn about additional tools you can use to manage your AWS implementation. The AWS Tools for PowerShell enables you to script operations on your AWS resources from the PowerShell command line. You can perform many of the same actions that are available in the AWS SDK for .NET. You can use the AWS Tools for PowerShell from the command line for quick tasks, such as creating and configuring security groups, launching instances, creating and deleting S3 buckets, performing IAM tasks, such as assigning a role to a user, or publishing custom CloudWatch metrics. The AWS Tools for PowerShell provide a set of commandlets, which are commands that are used in a Windows PowerShell environment to perform an action. The AWS Tools for Windows PowerShell support the same set of services and regions that are supported by the AWS SDKs. Let's look at some examples of how to perform a variety of common systems management tasks with the AWS Tools for PowerShell, such as, here is an example PowerShell command to launch an EC2 instance. In this example, you can see the PowerShell command to view EC2 instance details by filtering on the reservation ID returned in the previous example. This example shows how to use AWS Tools for PowerShell to create a security group in Amazon VPC. And here's an example of using AWS Tools for PowerShell to create an S3 bucket. And finally, here's an example of how to create an IAM group and an IAM user. The concept of infrastructure as code is fundamental to cloud computing and differentiates the cloud from more traditional IT environments. The AWS SDKs and APIs provide you with tools for managing applications built on AWS infrastructure as code. AWS provides SDKs that are language specific. These SDKs provide APIs for the languages shown here. Both the SDKs and APIs enable a developer to incorporate the connectivity and functionality of the wide range of AWS services into their code without needing to write functions from scratch. The AWS SDKs have extensive documentation about how to use them, including guides on how to get started, developer guides, API references, and community forums or developer blogs. To get more information about the SDKs, search for AWS SDKs in the AWS documentation. AWS CloudFormation is another useful tool you can use to create, update, or delete entire AWS infrastructure deployments predictably and repeatedly. With AWS CloudFormation, you can model an entire infrastructure in a single text file written in JSON or YAML. You can then use the text file template to define all the desired AWS resources for a stack. An AWS CloudFormation stack is a collection of AWS resources you can manage as a single unit. In other words, you can create, update, or delete a collection of resources by creating, updating, or deleting stacks. Resources in the stack can include EC2 instances, Amazon Relational Database Service instances, or RDS-DB instances, virtual private clouds, also known as VPCs, and many other resources created from AWS services. With AWS CloudFormation change sets, you can also preview how proposed changes to a stack might impact running resources, such as whether your changes will delete or replace any critical resources. AWS CloudFormation change sets only make the changes to the stack after you decide to run them. Another feature of AWS CloudFormation is drift detection. Performing a drift detection operation on a stack determines whether the stack has drifted or changed from its expected template configuration. If the resource in the stack supports drift detection, the drift detection operation returns detailed information about the drift status of that resource. AWS OpsWorks is another useful tool for managing instances that use Chef and Puppet. Chef and Puppet are automation platforms that you use to automate the configuration of your servers. AWS OpsWorks enables you to use Chef and Puppet to automate how servers are configured, deployed, and managed across your EC2 instances or on-premises compute environments. AWS OpsWorks has three offerings: AWS OpsWorks for Chef Automate, AWS OpsWorks for Puppet Enterprise, and AWS OpsWorks Stacks. To learn more about configuration management services, search for AWS OpsWorks in the AWS documentation. Thanks for watching. See you in the next. It's now time to review the module, wrap up with a discussion of a practice certification exam question, and introduce the labs for this module. In this module, you learned about the purpose and function of AWS Systems Manager and its related features. You also learned the purpose and function of AWS tools for PowerShell. You now know some of the additional development tools used for tooling and automation, such as SDKs, AWS CloudFormation, and AWS OpsWorks. Finally, you can set up hosting for a static website on Amazon S3. Great work. Let's take a look at a sample certification question. Let's take a minute to review a sample question that could be on a certification exam. Review this sample scenario and look for any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. You can now look at the answer options. Keeping the keywords in mind, look at the answer options and try to rule them out based on the highlighted keywords. The best solution in this case is AWS Command Line Interface. Now it's time to complete the Module 2 guided lab using AWS Systems Manager. You will also complete the Module 2 challenge lab, create a static website on Amazon S3. Thanks for watching. See you in the next video. Hi there, and welcome to the computing module. In this module, you'll take a look at how you will manage, secure, and scale your compute instances on AWS. Then at the end of the module, there's a hands-on lab where you get to use the AWS CLI, the AWS Command Line Interface, to create an Amazon Elastic Compute Cloud instance, which you can refer to as an EC2 instance. The C2 and EC2 are the two C's of Compute Cloud in Elastic Compute Cloud. This EC2 instance will form part of something called a LAMP stack, which stands for Linux, Apache, as in Apache HTTP server, MySQL, and PHP. By the end of this module, you'll be able to describe virtualization technology using Amazon EC2, and you'll know the differences between the various EC2 instance types and their various storage options. You'll also learn about the networking components that must be specified when you launch an EC2 instance and the difference between user data and metadata. And you will be able to create EC2 instances and also explain more about what aspects of cloud computing Amazon is responsible for and what aspects the customer is responsible for. Okay, you're ready to go and get started.